Hello, I'm Mark, and welcome to part 2 of my Unreal Engine tutorials on how to build a physics-based static thruster setup for your Unreal Engine games. So in this video, we'll be picking up from where we left off in our previous video by moving over to our vehicle simulation component, as seen right here, where we can go ahead and integrate that thruster setup into it. So as always, let's do a quick little recap of our previous video before we dive right in. So in our previous video, we went ahead and created our vehicle movement traits. So this is a system that's going to allow us to have both the vehicle simulation inputs that we define there, as well as our direction and state that we defined here, right? And it's going to allow us to then connect that into the vehicle movement traits so that this data packet can then be moved up and down the network if we choose to create a networked version of this. Okay, so after that, we went ahead and created our physics static thruster setup. And again, this is a object which has some other sub-objects in it. So, but again, a tag, whether the thrust is enabled, we have our mapping right here, so we know which input type is going to be controlling this thruster. And then we have our force direction configuration, which is our how we define direction. Thrust point, which is where our thruster is located, and then we created another object here to create for our thruster force to then calculate how much force we're bringing or where we're bringing that force back. And then finally we get our get force, which will bring back our vectored force. All right, so that was everything that we did in the first video. So let's move on to the vehicle simulation component. So in the vehicle simulation component, we're going to need a reference back to our simulation configuration file where our simulation setup is set. So I'm going to do that real quick. So I'm going to put an include, and we're going to say simulation. So under simulation, and there it is, simulation configuration. That's what we want. And that will link our simulation configuration code here into our setup here. All right, so next, I'm just going to go ahead and bring in an enumerator. So since we're going to be taking throttle settings from both the X, Y, and the Z, I could either write 3 separate functions, or I could just write one function and then pass in 2 parameters. The first being the value, and the second one being an enum on where we want to map it. So that's what this little enum is going to do. It's just going to help with mapping, so I don't have a lot of, somewhat similar functions. So again, throttle X, throttle Y, throttle Z, and that's pretty much how we're going to set that up. So that's our enumerator. All right, next we're going to come down. So we have our reference to our simulation inputs as well as our simulation state. And we don't need to do anything in this public section. So we're going to come down to the protected section here. And all I'm going to do for now is just add in a reference to our physics static thruster setups. And I'm going to be putting this in an array. So by doing this, we can have as many thrust points on our vehicle as we want. And we can set it up. So you can set it up to be as real or pseudo-real as you want and create as many points as you want. It's up to you. So static thruster configuration is the variable which we're going to be setting that up under. But again, we're just using the array template of type physics static setup. All right, so that's all we're going to do there. So moving on, we have begin play, initialize, and simulate physics tick. So we're going to add some more functions to this setup here. So the first one I'm going to add is the create thruster setup. So this is an initialization function that we're going to use, and this is going to help us set up within the begin play our thruster setup. So while we have the data, there's some tweaking that we need to do, especially when it comes to going onto the skeletal mesh or the static mesh and finding either socket locations or bone locations. So that's where we'll do some vehicle setup here that we need to do before we can actually run it. And then next, again, if we're using sockets or bones for locations, for thrust points, we're going to need a function to go find that. So that's what this one's going to do. Next, and right now I'm just going to put the functions in, and we'll come back and do implementation after we define the functions. Next is going to be the update state GT. And again, this is where we're going to be updating the state on the game thread. And this is going to be run within the tick component, which is down here. Clearing inputs is always a good thing. Again, we need to make sure that inputs get consumed once they're used so that we don't have any dirty values that could be throwing our simulation off. So that's what that's going to do. And then, because we have the ability to map a thrust point to a series of thrust points to an input, we're going to need a way to apply that mapping. So there it is. So we have the apply input mappings. We're also going to need update simulation. So again, delta time and handle, but we need to be able to update the simulation. And we're also going to need to apply the thrusts. And I'm just breaking this down into nice little discrete functions just to kind of keep things clean and organized within the code. So I think that that's going to do it for everything for now here. Right, so then under public, we're going to add some additional functions. So again, we want to be able to take multiple throttles. So here's our function to go set our, so this is going to be called from the blueprint, or from the, the class, the actor class, the pawn class, or the, that we're using physics-based movement on. So again, there's our throttle input. And again, it's going to be value and x-axis, or the axis that we want to put it on. And then we also have our set yaw, our set pitch, as well as our set roll. So throttle, yaw, pitch, and roll. And then lastly, we just need two more blueprint callable functions. So this one is our reset simulation. So in case we need to do a reset or have a button to do a reset within the game for any reason, this will go ahead and clear out any data and reset for us within the game simulation. And then, since we know what the state of our vehicle is, it's probably good to have a way of accessing this state simulation or simulation state structure. So if there's information that we want to, say, drive in if we wanted to create a HUD that showed us how fast we were going and what direction we're going, we could do that. If we needed to create other little subsystems outside of this to help better manage the moving the vehicle on the inputs, we could do that too. So that's kind of what that's there for. And again, I'm just force inlining this one, since all we're doing is we're returning back our simulation state there. And it's a const, so we can only pull, we can't update. All right, so, and then lastly, I'm just going to go ahead and under private. So under private, we're going to be having these raw input values, and this is going to make more sense a little bit later on down the road, but for now I'm just going to put it in there. But what we're going to do is we're going to have the raw inputs come in, and then we're going to then map those raw inputs to the input simulation input here. And I'm creating that separation now so that later on in the series that I'm planning to put together, we can create some ways to kind of help to process that raw data into a more refined input for our simulation. So that's what's going to happen there. So, but we're going to put this in right now so that we don't have to go and make too drastic alterations later on. So, all right, so that should be everything that we need as far as our simulation here. So I'm just going to hit save. So now let's go ahead and start doing our implementation. So first off, I'm just going to move over to the implementation. And so as you can see here, we've already got a little bit here. We've got the begin play, we have the initialize, the simulated tick, and then we also have the tick component. So let's go ahead and fill those in first. And I'm going to start with tick components, since it's probably the easiest one to do right now. And so in addition to the super tick component, so we're just going to add the update state GT. So again, updating the state on the game thread. So that's that function there. And then on the simulated physics tick, so we'll just go get that. So here we've got the handle, we've got the simulated physics tick. We're just going to do, so the first thing we're always going to do, again, just like on the GT where we're doing our update, we're also going to do this on the physics state too. That way we're ensuring that we have the most up-to-date information on the position of our physics body as it's moving. So again, we're just going to run the update, passing in the handle. This is our gravity Z, and then there's our delta time. All right, so next I'm just going to add, for some debugging purposes, I'm just going to go ahead and add these little error messages. So again, this is coming back from our physics movement component, so we can, once we turn that on there, we can access this information. So this is again forward speed, right speed, and up speed. And I've color coded it, so forward speed is red, right speed is green, and up speed is blue. It's kind of like the same colors that are the Unreal Editor uses for its orientation as well. So kind of help to kind of figure out where we're going with that. And then the only other things that we need to do here, and I'm just going to bring all three of these over, is apply inputs. Once we've applied the inputs, then we'll update the simulation, right? And then the last thing we want to do is, after we've updated the simulation, we want to apply forces. So a couple of people messaged me when they were building out the physics component and they were trying to run it from the blueprint, and they were wondering why it wasn't running. And that's probably because I designed it so that you had to call the apply forces. And so what happens here is in update simulation, we're kind of filling a queue, filling all these queues with all of the deferred force data. And then what we then do is we then tell it to apply right here. So this will then tell the deferred forces component to say, okay, you've got all this data, now apply it, and then go back to, and then once you've applied it, it will then lock it. So then we can then start filling up the queue again. And so that's all that does. So applied forces. All right, so now that we got that, let's go up. Oh, a couple more things to do while we're here. First off, we have the initialization. So if we want this thing to run, if we want this to run across the network, or we want to have the ability to, whether we want to, or whether we're intending to or not, we need to make sure we have the initialized network physics movement. So this is, again, the code is using network physics prediction. So this is going to check to see if that variable is set in the project settings. If it is, we'll check to make sure that we actually have a valid network physics component. And if we do, then we'll then take the traits that we defined here in movement traits and go ahead and create history data and self-reference the component by using our C++ this pointer. And that's all we're going to do there. All right. So let me just... And then lastly, while we're still doing the boilerplate stuff, we have our begin, and the only function we need to add in here for now is going to be the create thrust setup. So again, there's a little bit of processing we need to do before we start this thing, and that's just going in and making sure that we've got our locations in the right place for our thrust points, and that's what's done here. All right, so now that we've got all of this boilerplate stuff done, I'm just going to go and minimize this for real estate purposes. And let's go over to our component. So we're now in the H file, so let's go ahead and start putting the implementation for all of these new functions. So first off, create thruster setup. So I'm going to go to potential fixes. All right, so here we are. So in create thruster setup, all we're going to do is we're just going to do a for each loop. So we're going to do a for each loop over the array. So this is our, again, static thruster configuration. And we're going to be doing this by reference. So I've got a little ampersand here. So if you're, so this is all ensure that we're not taking the actual object, we're taking a reference of the object. And because of that, we can then go ahead and manipulate the data on there. So first we'll check to make sure that this referenced object is, if it has a bone socket or a name, we'll want to know. So if it's not none, we put a socket or a name in there, then we'll go ahead and run the get bone or socket location function to go ahead and get that location for us and set it in the force location here. So, and that's all we're going to be doing for thruster setup. And so then we've got the function that it's using. So I'm just going to go to potential fixes and get that code. So I'm kind of set this up so that we can should be able to do this for both statics and for skeletals. So what we got here, I'm just going to minimize this. So what this does is it's just going to say, first, let's check to see if this is a skeletal. So what we're going to do is we're going to take the root component, right, of the blueprint and cast it to the mesh. And if we have a good cast, it is a skeletal, then we'll say, first, let's see if we have a socket. So we'll go check to see if there's a socket by that name. If there is, then we'll go ahead, and this is just, again, bringing back an object so we can use this pointer check. Then if it's good, then we'll say get socket transform, right, by the socket name, and then what we want is the RTS component, and then all we want is the location of that socket. If we don't have a socket, then we will then defer to say, okay, well, if it's not a socket, is it a bone, right? And then so if it is a bone, we'll just say, here's the name again, find the bone space, component bone space, and again, this is returning actually a vector. So if it does find one, it'll return the vector along the XYZ, and if it's not, it'll return a 0, so we don't have to worry about checking it. And then if it's not skeletal, then we'll say, okay, well, let's see if the root component is a static. If it is a static, okay, does it have a socket? If it does, right, then we'll go ahead and pull that information. If it doesn't, or if we can't find a socket by that name, then we'll then return a 0 vector of our own. And so that's all we're going to do there. All right, so next up is update state GT. So again, potential fixes. So the first thing we're going to do here is we're going to do a simulation state update state GT again. So here we're going to go get the body instance, and that again is referencing from our physics movement component. So that's already done, set up for us. And then get the gravity Z, that's already done for us in the movement component. And then the delta time that's being passed through on the tick. And then this is where we're going to go into our raw to simulation mapping. So I'm actually just going to go ahead and write these out real quick. So just going to grab this. So here we are, we have the axis, and so this is going to go to raw X So then we have simulation inputs dot x, y equals raw. And again, this may seem like it's overkill right now, but later on as we kind of continue to develop our vehicle movement component, this will, we'll make a bunch of changes here, so we can do some input processing. Simulation inputs dot z equals raw z, and then we have the simulation for pitch equals raw pitch. And again, pitch roll equals raw roll, and then simulation inputs. So yaw equals yaw inputs. Okay, so that is everything we need so far. So again, this will pass the data coming off the raw and putting it into that. And again, it seems like it's duplicate right now, but it'll make more sense a little bit later on when we get into creating systems to help kind of massage the raw input data for us. And then last, after everything's said and done, we will want to do a clear raw input. So I'm just going to go grab that function over here. So again, once this has been passed through, we want to make sure that we consume it and set it back to its default state, ready for the next input. All right. Next, clear raw inputs. So I'm just going to say show fixes. And clearing this is pretty simple. I'm just going to go copy all this. Again, clear raw inputs. We're just going to set these back to their default 0 state. So I'm just going to minimize that for real estate. All right, so next, after we've done all that, we've got our apply input. So this is where we're going to do our mappings. So this is where we do our input mappings. So we're going to say show potential fix. And once again, I'm just going to go grab this real quick. So here, again, we're going to do another for each loop. Here's our list. We're going to take a thruster by reference again. And then within that reference thruster, all we're going to do is we're going to check to see what its control input source is. And then we're going to map the input simulation inputs to that input source. And we're doing it this way. That way, if you could have two main engines, so you could have two simulated thrusts, one representing your right engine versus your left engine, your top engine or your bottom engine, depending on how you want to set it up, right? And again, we want to map all of those engines to the main throttle source. So that's how we can do that. And we can do it for X, we'll do it for Y, do it for Z. Again, for pitch, if you're trying to pitch a vehicle over, you could have multiple pitch inputs, you could have multiple roll, and you could have multiple yaw. Again, really, it's up to you on how you want to set this up. Flexibility. All right, so that's the apply inputs. So then we've got update simulation, so I'm going to say show fixes. And so again, as it applies, we're just going to be updating these simulations. So here, for now, all we're going to do is we're just going to go and apply the thrust force. So this guy, again, is... So if we go back to our physics tick, we have our apply inputs. So the first thing we need to do is we need to make sure that we map all of our inputs into our systems. And that's done through this function here. And then we want to make sure that we update the simulation. And updating the simulation is pretty much, this is where we create all of our deferred forces before they get applied right here. So that's that. I'm just going to leave that for now. But that's all we're going to do here. And again, you could have, yeah, again, we're probably going to have, as this, series of tutorials moves on, right, I'm probably going to have more things in here than just apply thrust forces. But for now, it's just going to be that. All right, so moving forward, let's go to what's in that apply thrust force, which is right here. So let's go show potential fixes. And like anything, I want to make sure that we have a valid handler before we do anything. So again, we're passing that handle in. I want to make sure that that handle is valid before we do it, before we work on it. And then I'm just going to go grab it. And as you can see, I've got a little red squiggly here, so it means that we need to add an include, and that include is a reference to our physics proxy, single particle physics proxy. So there we have it. So okay, so that should fix the red squiggly. So here we are, apply forces. That's done in update simulation, which is done right here in the tick. And so all we're doing again is we're iterating through that list again of thrusters, and here we're going to say here's our center of mass. So we want the center of mass. We're going to zero out the z, since we only care about the center of mass on the x and y. And then next I'm just going to go ahead and set the world transform for altitude. Again, this is if we're using a curve and we want to do a thrust curve based on the altitude. Then here's our z, so this is where our vehicle is compared to the z on the z-axis. And then next we're going to then say from the state's world transform we want to get the position. And then so what we want to do is here's our thrust point location, and then we're going to take a look at the center of mass and do any offset based on the center of mass. So if the center of mass moves, then our thrust points will move, because our center of mass should not be moving for this simulation anyway. And then once we have it, again, so because we have a XYZ, we also need to make sure that we're rotating that force in the right direction as well. So as our vehicle over time is moving left, right, up, down, pitching and rolling, we want to make sure that the force is actually still pointing in the right direction. Otherwise, if we rotate the vehicle but the force isn't rotated, it could, it's not going to be, executing correctly, and we won't get the correct amount of force because it's not in line with the new position of the vehicle. So to do that, again, we're going to do another rotate. So again, we'll take the world transform, get the rotation, which is going to give us our quat. Then off there, we'll then just go ahead, and here, this is where we're going to say get the force that the thruster is calculating for us, and it's going to take that force and it's going to rotate it for us. So then what we have is our rotated force, and then we're going to put our rotated force into the add force at position, and then this is going to start queuing up all of our thrust points into the queue so that it can then be applied when we're ready to apply all of our force points, or all of our thrusters to the simulation. All right, so that should do it for everything in protected. So, and we've taken care of the tick component. Let's just double check. Yep, tick's just got the update state GT going right now. So I'm just going to close this and minimize this. So now all we need to do is we just need to get our input functions set up. So to do that, I'm just going to go ahead and say show potential fixes. And so for this one, this is our set throttle. So again, based on the axis that's being set, we're going to take the value and then we're going to map it. And we're mapping it to the roar for now. And here's our clamp. So again, we're going to clamp it to make sure that this value is between -1 and -1, because that's what we're expecting. And we're going to do that for both X, Y, and throttle Z. And again, if for some reason we add a new enum and we forget to put a mapping in there for some reason, you know, I've got a little error message as a catch-all on the default. Alright, so your input. So these one I'm just going to keep as separate functions. So for your input, we just need to make sure that we're mapping it to the your. So here we are, again, just doing a quick clamp. And then we just make sure that that's that. Again, real simple. Pitch. Same idea. So there it is. Just gonna keep saving. And same for roll. And there it is. So again, we're just clamping it to make sure that we've got a legitimate value coming in. Alright, so after that, we just got one more function, and that's our reset simulation. And so in reset simulation, we're just going to do two things. So this is an input that in case we just need to reset everything, what we're going to do is we're going to reset on, we're going to clear all the inputs on all the raw inputs in the component, but we're also going to make sure that we also reset any simulation inputs. And again, it seems a little redundant right now, but when we start getting into these, massaging these inputs and into maybe even interpolating inputs over time before we put them into there, it'll make sense, a little bit more sense, but we need to make sure we just clear both of them out. All right. So I think that should do it for everything that we need for our vehicle simulation component for right now. So let's go ahead and do a quick compile, make sure everything looks good. So I'm just going to hit that. All right, good compile. All right, so that's going to do it for this video on setting up the components. And so I think, so I think what we'll do is then in part 3, we'll go into the editor and we'll go ahead and create a blueprint and set up our static thrusters, see what that looks like, and get things working so we can control a cube with using nothing but thruster inputs. So once again, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel, and I will see you again in the next video. Cheers and bye.